So matrix multiplication is very, very useful, okay, when it comes to multiplying, obviously, two matrices together. Well, that's a given, okay? And the way that works is, obviously, as a business or as an individual, you're probably not going to make a matrix of all your numbers and then calculate them, okay? But like I said, if you ever get into admin, or if you ever get into work that works with IT, a lot of computers, this is what they do. This is what they use in Excel, actually, if you didn't know that. So Excel uses a lot of matrices. If you are building, like I said, some sort of computer program, this is what they use. Okay, because what it does is it helps to communicate and crunch numbers together without you having to do anything. Okay, and helpful again for a lot of different other applications. So, for example, here, cafes A and B charge the same price for a coffee. All right, so already they've got some information there that's important. Same price for a coffee, an orange juice, a muffin, and this is shown in table 1. So here's table 1, and you've got the price for cafe A and B, and they're both charged the same. Okay, the number of sales in each item of each cafe on a particular day is shown here. So this is how much they sold right here. So this is the price, and this is how much they sold. Okay, use a matrix multiplication to find a matrix that represents the total revenue of each cafe on these items for that day. Right, so when you get a question like this, the first thing you need to do is put both of your put the information into a matrix. So it comes in a table, make it into a matrix. You can call it whatever you like. Okay, I'm going to call this matrix here, we'll just call this P for price. Okay, so make your P matrix. Now I can see here, oops, sorry guys, P matrix here is going to be a row matrix. Okay, so let's put that into a row. No, actually, no. Okay, let's read this properly. It comes in a row matrix, okay, but when you multiply this, okay, have a think. This already looks like it's going to be, well, from initial value, it looks like it's a 1 by 3. Okay, you might want to arrange it as a 1 by 3. And then when you arrange this, it's going to be some sort of 2 by 3 matrix. Now, what's wrong with this? So if I have a 1 by 3 and a 2 by 3, can I multiply that? No. If I have a 2 by 3, if I swap it around, and a 1 by 3, can I multiply those? No. Okay, so something's up. Okay, I can't turn this into a row matrix. Anyone know what sort of matrix I should make it? Good. Make it a column matrix. Okay, because remember, the principle is what we want to do is you want to be able to multiply all of this with all of this. Okay, so in order to do that, it has to be row times this, but as a column. Okay, so let's change table 1, and we'll call it P into a column matrix. Okay, because that will enable us to multiply it. So you've got coffee, orange, and muffin, and the prices are $3.5, $5, and $4.5. Okay, so that's the first thing you need to do. First, turn it into some sort of matrix. Now this, I'll make it into a column matrix, because what I want to do is multiply this with these numbers here. Okay. All right, now that's one matrix, and then the second matrix is this bottom one here. Okay, this bottom matrix down here. Now this is this matrix we can leave as it is. I'm going to call this matrix C for just the cafes. Okay, we'll just leave it as a normal 2 by 3. Okay, so you've got coffee, orange, muffin, and then for cafe A and cafe B. Okay, cafe A has 96 coffees, 24 orange, 32 muffin. Cafe B has 124 coffees, 20 orange, and 16 muffins. All right, so now we've got the proper matrices that we need to use. So this is where some elements of your Year 12 will come in, right? So this matrix here, you might have thought, oh, I'll make that into a normal row matrix, but when you try to multiply them, it's not going to work. Okay. All right. So looking at this now, this matrix is a 3 by 1. and this is a 2 by 3. Okay, obviously you can't multiply them like that, so you'll need to flip them around. So you need to make it so that it's C times P instead of P times C, yeah? So let's put that in. Oh, no more space. C times P. Okay, so C matrix right here. Sorry. Ooh. Alright, so this matrix, put it down here. So we want to use this matrix, and you want to multiply it with P. Alright. Magic of technology. Sorry guys. Alright, so these matrices, remember I've flipped them around so that you can actually multiply them. Okay? Okay, I'll put this here. And P matrix, I'll just write it. Too much effort. So 3.5, 5, 4.5. Okay, so remember the principle of multiplying matrices? Row times column, row times column. Yeah, this is a 2 by 3, and this is a 3 by 1. So now it's doable. Okay, middle numbers are the same, and the outside tells you that it's some sort of 2 by 1 matrix. Okay, so when you multiply these, it's a 2 by 1, so it's going to be 2 rows, 1 column. Give yourself space to do it. And what you'll notice is, when you do these questions, okay, what I'm multiplying is Cafe A with these prices. You see that? So that means on the top row, it's going to be all of Cafe A. So, and then the bottom row is Cafe B times these prices. Okay, so that's what's happening when you're multiplying the matrices. Now I'll use my calculator because it's too much. All right. So first one is this row times this column here. Okay, let me just make this a bit smaller. Okay, so this row times that column, so that means 96 times 3.5, so we get 96 times 3.5. Now, ideally, okay, you could actually use your CAS for this, okay, and that's totally fine. That's probably what is expected, but we'll do it by hand for now. So 336 plus 24 times 5, so 24 times the 5, which gives you 120. So you're not going to be expected to do this by hand, yeah? All CAS. And then 32 times 4.5. So on your CAS, this will take you like 2 minutes. Okay, so that's the first row. Done. Now we do second row. Okay, so we do this row times this column now. And what you'll see is that's all of Cafe B times these prices. So you've got 124 times 3.5, and that'll give you 434 plus 20 times 5, which is 100, yep, plus lastly 16 times 4.5, and that'll give you 72. So now we add them together to get your final answer. So it's a 2 by 1, remember that. And I like to actually label at least the columns, yeah? You can do the rows, the rows. So I know what's happening. And you can call this prices if you want to. Okay, because that's what they are, yeah? Or actually not prices, it will be revenue. That's the one. Depending on the context. Yeah, or sales. That works too. But make sure you name it so you know what you're looking at. So just add them all together now. Yeah, so 336 plus 120. Oops. Yeah, thanks. Plus 120. This is so hard. 120. Yep. Plus 144 equals 600. Okay, and then for the bottom one, we've got 434 plus 100 plus 72. Okay, and that equals 606. There you go. Okay, there's our answer. Alright, so we've got now the total revenue for Cafe A and then Cafe B. So we can see that Cafe B made more money. Okay, you might get a question, which cafe made more money? Then you talk about, well, from our calculations, Cafe B obviously made more money. Okay, on that day. We'll just do one more example, so we'll skip the second one. We'll do this one, and we'll use that CAS for this. So get your CASs ready so that it's nice and easy. It'll only take you a minute. Number of goals in behinds kicked by some AFL teams during the previous round of matches is shown below. Okay, so you've got here number of goals and number of behinds for each team. Adelaide, Brisbane, Carlton, and Collingwood. This is obviously wrong because Carlton should be on the top. I'm kidding. I don't follow football. So now we use a matrix multiplication to represent this and multiply these numbers, okay, with one another. So you'll find here you've got a bunch of numbers that's already been arranged for you, but one of them you might need to rearrange into some sort of column matrix, okay? I find that to figure out which one it is, if you look at this question, which one did we use? It's the price for each item, yeah? That's what we turned into a column matrix. If you look at this question, what should we turn into a column matrix? Probably the goals and behinds, yeah? Because what you're going to do is it's going to be this row times some sort of column. Well, it has to be this column, but you're going to make it into a column matrix. So let's do that. So let's do goals. Actually, let's do teams. So one matrix can be T for teams. And you're going to make it into a 4x2 matrix. So 4 rows, 2 columns. Alright, so you got 9, 20, 7, 15. So 9, 20, 7, 15. And then you've got 9, 9, 8, 10. And make sure you know what's which. So these are your goals, these are your behinds. And then we'll name each team. So we'll just call it by the first letter. Adelaide, Brisbane, Carlton, Collingwood. Call this CA for Carlton, CO for Collingwood. Yeah, Adelaide, Brisbane, Carlton, Collingwood. So that's matrix T, and it's some sort of 4x2. And then for the second matrix, we'll just call it matrix P for points. Okay, so P for points, we're going to make it into a column matrix, yeah? So that we can actually multiply it. So 6, 1, these are for goals, these are your behinds. So remember, the idea is you want to go row by column. And the reason why we made this into a column matrix is that you can't go, say for example P was this, 6 and 1, you can't multiply this with this, okay, because there's not enough numbers. So you have to arrange it into a column matrix instead, okay? All right, so let's do this. We're going to do, in this case, write the order down. You know that this is a 4x2, and you know that this is a 2x1. So that'll work because the middle numbers are the same. So it has to be T times P. So T multiplied by P matrix. Okay, so let's put that in. T matrix times P matrix. I want you to put that in your calculator, okay? Actually, no, let's write this down first. Sorry, guys. Write it down. So T times P, so T matrix times P matrix. So we're doing it all properly. So you got 9, 20, 7, and 15. Okay, you've got, we would have to do it by hand. Yeah, no, not by hand. So in your calculator, actually in the SAC, all you'd have to do is, I think what it'll ask you is just show that you've put it into a matrix and then multiply them to get the product. Like show the product of TP. And it might be like I would say it'd be like a one mark question because it'll just ask you for the answer. So you won't need to show all this. But if you were showing it by hand, then you'd have to obviously show all of this too. Okay, but if it just says show the product of TP, then you can just rip out your calculator after you've done this and just show you your answer. But I want to show you the full way because I'm cool like that. 9, 9, 8, 10 multiplied by P matrix, so it's going to be a column matrix.
Sir,
Yes?
are you going to show us how to do this on our calculator?
Yes, I'm going to do it now. So, right now. Yes?
I really can just like put them both in and then times it, but is it okay if we like would we get the same thing if we put it through, labeled it, and then just times
Like T times P?
Yeah.
Yes, you would get it. Because if you labeled it, the calculator would know, oh yeah, it's T times P. But if you just put the matrices in, that also works. Okay, so let's put these into a matrix, guys. Oh, actually, before we do that, what's the order of this? This is a 4 by 2. And the second one is a 2 by 1. Sorry, 2 by 1. So that means it's doable, okay? All right, so let's put them in the matrix. Just going to put this here. Okay, so there's your matrices. I'll beat you to it. If you've forgotten how to do it, just watch me do it. All right, so on your calculator, remember you use this button, and then you pick whatever matrix you want. But remember, that's a 2 by 2, that's a row, that's a column. You can use this one. This is a custom matrix. So we know that this is a 4 by 2, so 4 rows, 2 columns. Okay, enter, put your numbers in. So you got 9, 20, 27, 15, 9, 9, 8, 10. Okay, to name your matrix from here, put your cursor all the way to the right, press Control, and then var, and then call it whatever you want. In this case, we called it T, I think, for teams. So we'll just call it the T matrix. And then the next matrix is a 2 by 1. So make another matrix. You can use this one. This one will work because it's a 2 by 1, 6, and 1. And we'll call this the P matrix for P. So Control var P. Technically, you don't actually have to do that. If you just you wrote this matrix down, and then you went times this matrix, that'll also work, yeah? But if you labeled it, so you can call it T times P, and then you're multiplying it with P, you would get the same answer.
Well, how do you label it?
Label it? Okay, so if you've written your matrix down, like this, so let's say you've done this, yeah? Put your cursor all the way to the right, so you get like a red line.
Yeah.
Press Control, and then VAR, this button here, and then type in whatever letter you want to call it. Okay? So you can go T times P. So remember, you know those questions where it says it gives you matrix A, matrix B, matrix C? It's a lot quicker to label them and then multiply them rather than having to retype it. Okay, so there's our answer, 63, 129, 50, and 100. So I'll write that down here. So in your SAC, when you get a question like this and it just says show the product of T and P, if you just wrote the answer, I would give you the mark for it, full marks. Okay, because that's all it's asking you to do. You don't need to show working out. So now we know the score of each team, yeah? Adelaide, Brisbane, I think it was Carlton, Collingwood. So that's their scores.
Will we have multiple choice in our SAT?
Yes, you will. Okay, so there's the scores. We'll skip this example, and I might actually stop there now, because we'll do a bit of that later.